Our focus today is on parallel and perpendicular lines and what their equations look like. So before we get started, I just want to recap again what we know. When you write the equation of a line in slope-intercept form, we write it as y equals mx plus b, or we've been really calling it y equals ax plus b, thinking of this as function form. So whatever your rate of change is, or your slope, if we think about this in terms of a unit rate per step in x, every time I go over 1 on x, how much do I go up on y? If I go over 1 on x, I go up the same amount. And every single time I do this, in this particular example, you can see if I go over 1, I have to go up a half. So that's why we're taking our rate, a half, times by x, is to figure out what the y value will be. Now this is only going to give us our y value if we're starting at a height of 0. If I go over 4 units, I'm going to go up 4 times a half, or 2 units. That gets me my y. But right here, when I went over 4 units, I went up 2 units from an already set height of 5. So that top equation is going to have to say plus 5. That's my y-intercept. Whereas my middle equation is just 0.5 times x. The plus here is just plus 0 because it started at a height of 0. Whereas my last equation, y equals 0.5 times x, again gets me my amount of rise per unit run, but I'm actually starting at a height of -3, so I've got a -3 there. Now typically we're going to write the slope as a fraction. Helps us keep it more exact, especially if it doesn't come out to a nice decimal. But in general, you'll notice all three of these lines, which are parallel lines, all three of these lines have the exact same slope. If I slide this line down onto the other one, you can see they are perfectly the same line. And the reason why they are the same slopes, or the reason why they're parallel, is because they have those same slopes. They're not going to get closer to each other. So how do you know if lines are actually parallel? We just kind of dealt with that. In these three lines here, if you think they look parallel, we can actually check it by finding some points and calculating the slope. It looks to me like we're going to be able to use these 2 points, and it looks like there's another one back here and probably another one right here. And so I can calculate my rise and my run. So right here my rise is 2 and my run is 5. So this one appears to have a slope of 2 over 5. Now I just want to confirm that I haven't named those points wrong, so I'm going to double check it, 2 and 5. And here again, this is 2 and 5. So I do actually have a slope of 2/5 on this one. This line right here, on the other hand, appears to have a slope of 1/2, because when I'm picking these points, each time I go from one line to the other, it's up 1 and over 2. Since those slopes aren't the same, they're going to not be parallel. When I divide this out, I get a slope of 0.4, whereas this one is a slope of 0.5, 1 divided by 2. Notice the slopes are close, and when I lay the two lines on top of each other, they're kind of close, but they're not exactly the same slopes, so they're not parallel. Come down and do this for my other line down here, see if it's the same. It looks like I'm going through that point. It kind of looks like I'm maybe going through this one, up 1 over 2. But notice if I keep doing an up 1 over 2, I'm actually getting further off of my line. So that must not be an actual point on that line. It looks like maybe this one might be. If I went up 3 and over 2, 4, 6, 7, over 7. So if I go down 3 and back 7, it appears I did fall on that line again. Now 3 divided by 7 has got to be awfully close to 0.5 because that line looks very similar. And it turns out that it's actually 0.428 stuff. This is what I get when I take my rise and divide by my run. So this line should be very, very close in steepness to that top one. And you'll notice that it is very close. And not as close, but still similar to the one in the middle. So to be parallel lines, they have to have the same slopes. Not close, but exactly the same. How about perpendicular? You'll notice that these lines, you can tell that these two aren't perpendicular, but these two appear to be perpendicular. So the question is, if two lines are perpendicular, what would we know about them? And I want you to pay attention to this line right here. It has a slope of 2 over 4, or 1/2. If I rotate it 90 degrees, So I'm going to actually take it and turn it 90 degrees. You'll notice how you see its rise and its run turning right with it. This line now has been rotated 90 degrees. Notice that its rise is -4 and its run is +2. So the slope of the perpendicular line, the 90-degree turn, is a -4/2 or -2/1. Every single time I'm looking at perpendicular lines, you're going to see that same kind of transformation take place, where the slope is simply the opposite reciprocal. So the sign gets changed because one of them is going uphill and one is going downhill. That's why we have a positive and a negative. But the reciprocal is what you saw when we rotated the slope. What was my run now is making up my rise, and what was my rise is now making up my run. So when I rotate that thing, I can see that my fraction is going to have to be inverted. My rise and my run are going to switch places, and I'm going from an uphill line to a downhill line. So if I want to know if two lines are perpendicular, I simply have to look at their slopes. They should be opposite reciprocals. So for these two lines here, this slope is up 1/2. This slope right here is down 1/2. Now those are opposites, but they're not reciprocals. And so you can see that this angle here is not a 90-degree angle. That's not enough. They're not perpendicular. That notation right there is notation for perpendicular. If we look at these two, though, we said that this one has a slope of -1/2. This one has a slope of what appears to be up 2/1. So -1/2 and 2/1 are perpendicular. They are opposites and reciprocals. And you'll notice if two numbers are opposite reciprocals, here's one fraction, the other fraction is simply its reciprocal and change sign. When I multiply them, what I get in the top and the bottom of that product is going to be just simply opposites of each other. That product will always give me -1. So we say a test of perpendicularity is to take the slopes and multiply them. If you get a product of -1, then the slopes must be perpendicular. So quick summary here, parallel lines would have to have the same slope. For example, if one line has a slope of 3/5, then the other line has to have a slope of 3/5. Perpendicular lines would have opposite reciprocal slopes. So if one of them has a slope of 3/5, the other one has to have a slope of -5/3. And remember, if I multiply slopes of perpendicular lines, I will end up getting a product of -1. You can see that right here. I get a -15/15, which is -1. So let's start with what's the equation of this line. You should be able to do this pretty well by now. We know we write y equals. We have to calculate the slope, which is up 2 and over 4, and we have to know where it crosses the y-axis, which is at -4. So we're going to have a line y equals okay, I just realized I made a mistake here. It's only over 3. So my slope is 2/3 x, but my y-intercept is -4. So what's the equation of this line? Y equals 2/3 x minus 4. Now, based on what you did the other day with writing equations of lines given a point and a slope, we want to write the equation of a line parallel to this one. But we want to pass through the point 2,7. So we know we got to go through the point 2,7. And I've marked that one up here. And we need to be parallel, which means we need to have the same slope. So we're going to use 2/3 as our slope. And I could come up and draw this in if I wanted to. Starting at this point, I'm going to go up 2 and over 3, or down 2 and back 3. And when I connect those up, I should get a line that is parallel to the one that I have down here. What we want to do is write the equation of that line. If you think you remember how to do this from yesterday, why don't you pause the video and try it on your own first, and then come back and check your answer. All right, if you're ready, I'll remind you what we did here. In order to find the equation of the line when we're given a starting point, we start by figuring out our change in x minus 2. So for any point on the line x, how far is it from our starting point? We multiply that by the slope, 2/3, and that's going to give us our change in y minus 7. This is point-slope form. Y minus the y of a point equals slope times x minus the x of a point. If you distribute and then isolate the y by adding 7, you can get it in slope-intercept form. Y equals 2/3 x plus 5 and 2/3. And if we come back up here and check this, this should make sense. 1, 2, 3, 4, 5, and 2/3 seems like a reasonable y-intercept for that one. Now, same idea, we're going to go through the point -3, 1, but this time we want to be perpendicular to the lines that we already have. So here's my point -3, 1, and I want to be perpendicular. So the first question is, what do we know about perpendicular lines? If I'm going to draw this, I need a slope. And what's the slope of a perpendicular line? If our original slope was 2/3, then we want the opposite reciprocal of 2/3. So 2/3 flipped over and changed to the opposite sign would be -3/2. That's the slope that we're going to be using here. And so if I come back up to my point and I go down 3 and to the right 2, or up 3 and to the left 2, I should be getting a line that is perpendicular to each of those other 2 lines that I've already drawn. Now it's just writing the equation, and you can see that the y-intercept looks like it's going to be a little bit less than -3. So we're going to do the same thing. We know that when I take my slope, of -3/2 and multiply it by the change in the x values, so x minus -3 or x plus 3, that change is going to be the change in my y values, so y minus 1. So slope times change in x gives me change in y. I distribute this through if I want to get it into slope-intercept form, and then I add 1 to both sides. Now I'm going to change this here. This is a mixed number, -4.5. So when I add 1 to this side, I'm going to be left with -3.5. And then there's the equation of that line. If I want to know for sure if this is the right line, remember that I can check my slope first of all. So this one was supposed to have the same slope as the original one, which it does, and this one's supposed to have the opposite reciprocal slope. But the other piece that I want to check is to make sure it's actually going through my point. And I check that by plugging in the value of x where there's an x and plugging in the value of y where there's a y and testing to see if that gets me the value of y that I'm supposed to have. Does it make a true equation? So here I get 4/3 plus 5 and 2/3, which is going to give me 5 and 6/3, but 6/3 is just 2, so this is 7. So that one worked. I know that that equation is the correct equation. When I come down and check this one, I'm going to do the same kind of thing. It's supposed to go through the point -3, 1. So if I put -3 in for x, and I multiply through and check this, I should be getting a 1 for y. So right here I get 9/2, which is 4.5, minus 3.5, and 4.5 minus 3.5 does in fact give me 1. So we're going to be practicing some more of this tomorrow in class. Make sure that you're understanding it. Go back and rewatch any part of this you're confused about, or find some other videos as well that might help clarify your confusion. Good luck.